Bismillahirrahmanirrahim. Assalamu alaikum. My name is Mohammed Asim. I'm working as DevOps engineer. Guys, in this video, I'm going to show you how we can set the highly available Kafka cluster in Kubernetes. So what we are going to do, we are going to set up this Kafka cluster in a Kubernetes cluster, which is the small cluster. And then we are going to build our understanding and move to EKS and GKE. So, guys, if you are working as a DevOps engineer or SRE, you might have a DevOps project to set up this highly available Kafka cluster. So, we are going to set up through Strimzi, right? So, what I have done, guys, I've created a repo for you guys, and I'm going to show you how you can easily set up all this. So, what you need to do, you have to simply watch this video till end. So, let's start. So guys, let me show you. This is my remote server, right? And I'm going to log into this. Further, I'm provisioning the EKS cluster, right? So this is our, I mean, AWS account, and this container has GKE, right? So if I navigate to this, and I've already provisioned this Kubernetes cluster, naming this DevOps Strimzi Kafka, right? So if I navigate from AWS EKS, so simply if I type EKS, you will see that our EKS cluster is going to be available, right? And it will be available here. So right. So I'm provisioning this 1.25 in EKS, and if I do kubectl get nodes, you will see that this cluster is available in GKE. Further, if you want to use Terraform code, I've already covered this in the Carpenter and EKS auto scaling area, right? And the repo is going to be available in this video. Also, I've added the link in this particular repo. If you want to provision the EKS from the scratch, all the stuff, you need to use this repo, right? And it is going to provision 3 node cluster, right? And other stuff I've covered, like Carpenter and all the stuff. So anyway, this video is regarding the Kafka setup. So let's begin. We are going to cover from the very beginning. So if I navigate to my machine, so you can use, I mean, your local VM like VirtualBox or VMware, so you can use the same stuff. But I have this remote machine, so I'm going to use this machine, and I'm going to later on destroy this one. So let me try to log into this. And okay, so guys, this is the blank machine. If I do, let me show you, become root, and this is the Ubuntu box. And if I do get etc os release, right, and this is the machine I'm using. So you can use this machine. This is the Ubuntu 22 LTS, right? So guys, what we are going to do from the start. So we are going to set up the kind cluster, right? So, okay, let's do that. So regarding the kind cluster, what you need to do, I mean, you need to navigate to my repo, and I will add the link. I think I forget to add the link. So here I'm going to simply search for the kind. Okay, navigate to this area, click repositories, and that is going to be the public repo. And simply I need to type here kind and press enter. So regarding the kind ingress in the next, I've added a video regarding that. So what we are going to do, I have this shell script. So click this guy, right? And okay, I'm going to simply open this in raw, right? And I'm going to simply run this. So copy this guy, and I'm going to paste it, right? So also let me add the link of this repository in the same repo which I've shared with you guys. So guys, I've added the link of the kind cluster, right? And I'm going to simply, I mean, run this particular script which I've added here. So this is the script, exactly the same chmod plus X, and I'm going to run this while, so run it. So what it does, it is going to install the latest version of Kind, right? Along with the Helm and to the kubectl utilities which we need. And further, what it does, it is going to make everything ready for us. And then definitely we are going to simply use that cluster to set up the Kafka. But once before it is ready, what I'm going to do, I'm going to use my cluster, which is a provision on the GKE. So what we are going to do, we are going to simply copy this command. So as from the start, what we are going to do, we are going to simply add this Strimzi chart. What it does, it is going to set up the operator for us. And if we see, let me copy this command from here. So let me simply paste this command here, let it paste, and so it will show the latest chart version regarding the Strimzi operator, and we are going to use the latest chart, right? And also we are going to see some of the values. So with these command, you can see the values. And if you want to see the all versions of operator, you can use this command, and you will see that we are going to use the latest version of the operator till now. Anyway, guys, we have added this particular remote repo locally. And what we are going to do, we are going to simply install the operator in our GKE cluster, right? So I'm going to use this command, right? And okay, seems to we have some issues because I've tapped it 2 times. So let me do that. Okay. So what it does, it is going to install the operator. What I've done, I bring this guy in this container. So in past, I've covered the videos regarding CASM desktop. So one of the lens is already installed here, right? Inside this, and one lens is outside. So outside lens is this one, which is on my Windows machine. But the G Cloud CLI and everything is available in this. And what if I navigate to this these namespaces, you see shortly Strimzi is going to be available. So what it does, if I navigate to this Helm releases, you will see the Strimzi chart is going to be deployed, and it is going to spin up one pod for us, right? So this is the, you see, I mean, replica set deployment. So it is going to revision shortly. And then what we are going to do, it is pretty much like a copy or pasting. So this operator, guys, does the controlling stuff. So what I've done, I've added the official document. So if you want to see the detail regarding that, simply you need to click this official doc. So in this, it is actually showing the this release 030.0, and we are using the latest release. So it is not much big difference, but what you can see, you can easily able to see the architecture regarding the Strimzi operator with Strimzi architecture. You see, uh, what does what it do. This is a Strimzi. We are going to use the Kafka cluster, like broker, Kafka broker, zookeepers, and I mean what operator does, right? So everything and detail is going to be available in this section. So also let me show you these parts, and from the official documentation, let me show you what each operator does. You see, if we start, what are the operators? Strimzi provide operators for managing a Kafka cluster. So currently, what we have done, we set up the cluster operator, right? So through Helm chart, and then automatically it is going to provision the entity operators and the topic operator, user operators. So simply what we need to do, from Helm, we need to install this cluster operator, right? So if I navigate to this section, so cluster operator we have set up with version I mean 7 37.0 right? So now what we are going to do, let's see if it is available. So it is available, guys. So if I navigate back to my documentation, so simply you need to copy and paste this command here. I'm going to show you what this command does. So it is basically just a YAML file, and even if you can create your YAML files or I mean paste it. So let me show you what it does. So okay, let it paste first, and okay, need to check. Okay, let's try to see. I'm able to see kubectl get nodes. Okay, let's try to do this again, or otherwise we will be creating a YAML file, right? Okay, so let's try to do one more time, and you see now it is created. So guys, now I'm going to show you. This is just a YAML file. You can create one YAML file from here and simply paste till here, right? So below I've provided this same YAML file. You need to simply copy this and use the command kubectl apply -f and apply this YAML file. So guys, this is the same file below. So what it does, we are going to set up the Kafka brokers, three replicas which are going to be highly available, and these are the ports on which those are listening, right? And this is the storage. I'm giving 100 gigabyte of storage to each Kafka broker, right? So it is going to be highly available, and it is going to create a PVC, which is the a persistent disk on the cloud. So if I navigate to this container, you see it is provisioning first. It is going to provision the zookeeper. Let me show you that. So it is going to provision the zookeeper. Once the zookeepers are available, it is going to then provision those broker pods. So those broker pods, you see, once those are provisioned successfully, it is going to spin up. And before spinning up, what it does, you see, it is going to provision the other operator as well. So we just provision the cluster operator through Helm chart, and rest of the stuff is copy paste, and it is going to then provision the other operator automatically, right? So if I navigate to this section, and if I navigate to the storage section, okay, if I navigate to the storage, okay, let me navigate to the storage area, right, to show you guys that we should have a persistent volume disk. You see, it is provisioning, and if you see the disk, like you see data Strimzi, like zoo for zookeeper, I'm giving the persistent volume of 20 gigabytes. You see it is provisioning, and if you see data Strimzi Kafka broker, and this disk is going to be of 100 gigabytes. So okay, and those disks are bound. So okay, let me remove this, and you see these are the disks. And if I, okay, let me, okay, this disk is bound, and let me check the size of this. So well, this is the disk attached to it, and if you want to see the YAML regarding that, so you will see the size and everything with regard to the attachment it has, and the disk size also will be available here. You see 100 gigabytes of storage, right? Anyway guys, these is the details regarding the persistent volume. Anyway, let's see what is the condition of our cluster. So if I navigate to this lens, you see our cluster is pretty much in ready state, but we need to wait for a while. So I mean, you see currently it is in pending state because of the number of um, storage. So if I navigate to the persistent area size, because some of the stuff you might see that it is going to be in pending state because some of the permission I have in this account regarding the disk size. So what I have, it is actually allocated 100 gigs. So it is just a demo, but if we apply the same in kind, although I mean it is a virtual 20 gigabytes of total disk. but it is going to provision all the stuff in kind. So let me navigate to the area and see if this is the stuff which we have set up in kind cluster, kubectl, get pods, or let's say we will see the default. If I do kubectl get nodes, so what I'm going to do, I'm going to simply bring this guy locally here, right? So this is the one which we have provisioned in our client cluster. So let me get out the contents of the context, right? And if I do config and simply I'm going to copy this guy, right? And from here, I'm going to copy this till end, and I'm going to bring this guy locally, right? So let's do that. And I'm going to simply add a cluster here, right? So, okay. And also let me stop this GKE because it is going to be stuck as in pending state as I discussed that because of the some of the permission. So anyway, you will get the understanding, right? So I'm going to simply close some of the stuff here which we have already discussed regarding the GKE, and I'm going to quit this app, and also I'm going to stop this container, right? So it is going to release some of the memory as well from my machine. So I'm stopping this sandbox, right? We don't need it. And if I navigate to now my Terraform, so it has okay, some issues which I will later on fix. Anyway, if I navigate to this area, and what I'm going to do, you see, I'm going to add this cluster, so it will definitely not going to connect. And if I do exit from this machine, and what I need to do, I'm going to do simple stuff here regarding the SSH tunneling, and I'm going to do 8443 and 0.0.0.0 and 8443, right? So let's try to connect with this guy remotely, right? So let's do that. So it is going to actually ask the password regarding um, our remote server. So let me do that. Let me connect with that. Okay, guys, regarding the Terraform, what you need to do, you need to simply rerun this command to fix this error. AWS auth config does not exist. So you can use this command to, fix this error. Let's try to rerun it and let's see what's happened, right? And regarding the cluster, we have already done the SSH tunneling, right? And let's try to see, let's try to connect with this cluster locally. So guys, this is our kind cluster. You see, we have these master nodes, right, and worker nodes. So if I navigate to the pods, and you will see that we have the stuff available regarding the kind in our local machine. So this is our local lens, and till now we will see the stuff regarding the Terraform. So we have run this particular command, right? And what it does, it is actually rerunning the command. And this error usually comes from the Helm AWS auth config. I will try to add the fix for this one because of this config map v1. So anyway, you see it is initialized, and let's see what happened regarding the EKS cluster. Although we have EKS cluster provision, right, and we need to check, uh, I mean, regarding and the we need to use this particular command. So let's try to wait for a while. Until then, what we are going to do, right? So we need to have a shell, one more shell into this guy, and I'm going to simply copy this command till here, and I'm going to take a shell. So what we are going to do, we are going to, use the CLI, and we are going to do SSH into this. So this is our kind cluster, guys. So I'm going to do the repetitive stuff, and you will see the 100 gigabytes bytes of this are going to be available here. If I do sudo hyphen I, right, and if I simply become a root, so if I navigate to this section, okay, I'm going to simply copy this command to add the repo, right? So version we have already checked. If you want to see more detail, you can use the other commands, right? And then I'm going to install this, right, on our kind cluster. So I'm going to simply use this particular command, and I'm going to paste it here. So as this is available in our kind cluster, so what it does, it is going to create the namespace Strimzi, and in the Strimzi namespace, you will see that this guy is going to be available. So let's wait for a while, and okay, it is deployed. So just where you see, this is the namespace Strimzi now available. So it is going to install this operator, cluster operator. And simply what we are going to do, we are going to copy paste the same commands, and let's try to do the same stuff what we have done in the GKE. Although I don't have permission to create a huge amount of disks there. So if I navigate to in this storage section shortly, here you will see the PVCs are going to be available. Although this, server is just 20 gigabytes of storage, but you will see 20 gigabytes related to Zookeeper and 100 gigabytes to brokers are going to be available, right? If I navigate to this PVC's persistent volume claims, you see shortly everything is going to be bound because of the availability of those pods. And let's excuse me, let's see what we have regarding the brokers. So once it provisions the broker, so we will see shortly regarding that. So if I navigate to the pod section, you see the other stuff is going to be shortly available, right? It is in the provisioning state. It will take some time, but it is going to be available, right? So till then, what we are going to see, you see our EKS cluster through Terraform is provision. So if I do AWS EKS update Q config, and there's this name of the cluster Cloud Geeks EKS dev, and the region is US East 1, right? So it is going to bring this cluster locally here. So if I do kubectl get nodes, and also I'm going to remove this section regarding the GKE. So you will see this is our EKS cluster. And regarding the Kafka, it is actually provisioning. Definitely, it will take some time. You need to wait for a while. And if I navigate to the persistent volume claims and persistent storage, definitely we should wait for it. And you see, some of the stuff in pending state, and definitely it will take some time. So further, once it is ready, then later on, guys, I'm going to show you on the monitoring stuff with KF prop in our Kafka cluster. So let it ready. Just wait for a while. You see, two of the pods are in green state, and let it run. So we are setting up three Zookeeper and three Kafka brokers highly available. So once these are ready, same stuff in kind which we have seen in our GKE is going to be available here. So let it run, and I already tested in the EKS, but definitely you can see this stuff here as well. So let it ready, and okay, same stuff what we are going to do. Let's try to simply copy the commands regarding the helm for our EKS cluster, right? And so it is available, and we are going to add the repositories, and we are going to now simply install the operator in our EKS, right? So for EKS, let me remove because of the doubling. Okay. So we are going to install the operator in our EKS cluster, and I will also bring this guy, in our lens. So let it install first, and then we are going to see. So it is actually working on it. So if I navigate to the persistent volume claims, you will see that 100 gigabytes regarding the Kafka brokers are bound, right? So although I just told you that it is a 20 gigabytes of disk, so let me show you guys from the disk size as well. So this is the disk size of the machine, and you see the actual storage. Okay, this one is the root volume. 53% we are already consuming, and we have added and the virtual 300 gigabytes to this kind cluster, right? Anyway, guys, and that is just for your knowledge. And we need to wait for a while. You see, everything is pretty much available. So, guys, this is now setting up these cluster entity operator, which I've shown you in the diagram, and the detail you can definitely see from the link. I've shown you also the official link of their YouTube channel. Strimzi, this is the open source project, and this is the setup we completed, guys. So I'm going to simply use this particular command for EKS here. So let me do that. And what it does, it is going to do the same stuff, provision the cluster in our EKS account. So if I navigate to this section, EC2, let me just refresh it. So this cluster we have provision, and you see this is created in EKS. And if I navigate to here, refresh it, these are the 3 nodes. But regarding the persistent volumes, you need to navigate to the volume section, and you will see the volumes are going to be available here, right? So let me show you this part as well. So, okay, guys, let me show you guys the stuff. So, it is in the provisioning state. So, and these are the disk size volumes. So, definitely, cluster is not yet available. Okay, but what I'm going to do, bring that guy locally. So, if I do get out the contents of this from my local container, I'm going to bring this guy context locally here. So simply I'm going to copy this guy and bring this guy here. One thing I need to tell you that I've already logged in on my host machine with my AWS credentials. So, okay, seems to be a config error. So, okay, let me do one thing. I'm going to copy this guy from my root context. Okay, it should be cube and config to slash mnt. So let it copy, and I'm going to simply, you see, it is now available on my host machine. I'm going to simply copy this guy, and I'm going to get rid of this and use this one. So click on this, you see, I'm able to access it, and now I'm going to connect with my EKS cluster. As I discussed, I've already logged in regarding the AWS access keys and secret access keys. That's why I'm able to access it. And if I navigate to the Strimzi section, you see it is provisioning the stuff. So if I navigate to the section regarding the storage here, persistent volume claims. So here I don't have any issues. You see everything is bound, and similar stuff. If I navigate to here, like kind, count, I mean, everything is available. So now, okay, we are going to, in the last, simply do the stuff regarding the installation of this monitoring tool, which I've added in the description here, KF drop. So simply, what I'm going to do, I'm going to okay, this is not the one. This is the matrix server. If you install the matrix server, guys, in your kind. So currently, if I navigate to this section, you see CPU and memory is not applicable. Simply copy this command, and what it does, it is going to install the matrix server in your kind cluster, and shortly it is going to provision one port in the namespace cube system, and the CPU and memory is going to be available. So if I click this guy, and from the when I get to click this A section, right, and click it again. So you see 20 seconds ago, and the status. Anyway, this is going to be shortly available. Once this is available, you will see the stuff regarding the CPU and memory utilization of those particular pods, right, guys? So see, this is now available, and shortly you will see the stuff, the CPU and memory regarding the consumption. It is going to be available here. You see, now it is available. So this is the matrix server. If you want to use in your kind, you can do that. So lastly, guys, as I discussed, if this is a KF drop, so what you need to do, simply copy this YAML file, and I'm going to simply create a one YAML file in my kind. So I've covered all the stuff regarding the EKS, GKE, and KF drop kind. So this is the last part. I'm covering KF drop.yaml, right? And press I for insert, and let's try to copy paste this guy, and then I'm going to simply apply it, compute apply -f this file. So I will show you. Sorry, this is the uh, values.yaml. So sorry, I forget it. So this is the file we need regarding the values.yaml. What I'm going to do, I'm going to simply clone this guy in the same machine, right? Let it clone. Once it is cloned, right, we are going to do cd into this kf drop slash shard, right? Cd into this guy, and I'm going to simply now override this one. So I've created previously that particular file, but now I'm going to simply override my values.yaml file because it has the detail regarding our Kafka cluster, which is this one I have added. So this is the, I mean, service we are going to connect our Kafka broker. So where it is come from, you need to navigate to the network section services, or you can use the command use kubectl sorry, navigate to this Strimzi namespace as well. kubectl get services in the namespace Strimzi. You will see the port regarding the 9092, which we are going to connect. So everything is going to be available, right? So this is what we are doing here. I'm showing you the stuff from the lens and also show you the commands, right? So simply, lastly, what you need to do, copy this particular command. What it does, it is going to install the EF raw chart in our namespace Strimzi, right? So it is installing from the UI. We can watch that. This is our Khan cluster. You see, this is the Kafka service. Navigate to this releases section from Helm. You can watch this particular chart is going to be available regarding the KF drop, and we are going to then simply do the port forwarding to this guy. So let me close the stuff in the EKS. It is working fine, and I think we're good. So let me close the additional stuff which we don't need anymore, because you see this is now installed. If I navigate to the pod section, you see that kept off. You see it is provisioning, so let it provision. And once this guy is available, we are going to simply do the port forwarding to this guy to see our highly available cluster which we have provisioned through Strimzi. So just wait for a while, guys, and we will see. Okay, it is now green, and which means it is available. This is the KF drop service. Scroll it down, port forwarding. If you don't specify any port, it is going to give it a random port, and it is going to open my default browser, right? So you see it has opened this in my browser, and the port is going to be this 57090, and we should be able to connect our um, I mean, with our Kafka cluster, and we can play with it, we can learn it, if we can use it if you are a student, or if you are, using it in a highly available professional production environment, you can use that. So let me try to create one topic here. I'm going to call this Ascent. So three partitions and replication factor is three, that's fine. Created. You can definitely use the CLI and the scripts available. Everything I will cover in my later, but this is the setup I need to show you guys. And if I click this guy and the async topic, you will see the number of partition, everything is available in our cluster. Guys, if you like the video, please like, share, and subscribe the channel. Have a nice day. Thank you.